All right, so in this part, we're going to talk about when your numerators are different and when your denominators are different. So here we have, to order two fractions with different numerators and denominators, we can use our knowledge of equivalent fractions to produce fractions with a common denominator and then compare the numerators. So here we're doing the same thing. We want to place the correct mathematical symbol in between the following pairs of fractions to make a true mathematical statement. So here we've got 3 on 5 and 1/2. So as you can see, different numerators and different denominators. So the tricks that we have previously learned don't apply here because everything is different. So what we're going to do is we're going to follow these instructions, which tell us that to compare fractions, they need to have the same denominators. So do you see here I have 5 and here I have 2? What I want to do is create equivalent fractions for each of these that have the same denominators. Now, to do that, we're going to find the lowest common denominator by finding the lowest common multiple of 5 and 2. So the lowest common denominator is simply just the lowest common multiple. It's the same thing. The lowest common denominator is the lowest common multiple. So what's the lowest common multiple of 5 and 2? Hopefully you can immediately recognize that it's going to be 10. If you need a bit of help here, what I've kind of done in my head is I've thought of all my multiples of 5. So that's 5, 10, 15, 20, 25. Then I'm thinking of all my multiples of 2, 2, 4, 6, 8, 10, 12, 14. And of course, these keep on going, don't they? They go on for infinity. Now, the lowest common multiple is what? Well, it's going to be 10 because that's the lowest number that both of these multiples share. So that means what I want to do is I want to create an equivalent fraction for a half, but I want the denominator to be 10. So if I'm starting with 2, what would I have to do to make that denominator 10? Well, I'm going to have to times it by 5. And if I times the bottom by 5, it means I must times the top by 5. So that means what I'm going to end up with is 1 times 5 is 5, and 2 times 5 is 10. So 5 on 10 is an equivalent fraction to a half. And I think we'll all agree with that, wouldn't we? That makes sense. And then we're going to do the same over here. So remember, we want to make this 5 into a 10. So that means I'm going to times it by 2. Now, if you times the bottom by 2, you must times the top by 2. 2 3s are 6, and 2 5s are 10. So here we've got 6 on 10 and 5 on 10. Now, which of these is the bigger fraction? Well, because our denominators are the same, we just need to compare our numerators, and the one with the bigger numerator is going to be bigger. So that means 6 on 10 is going to be bigger than 5 on 10. So that means we can say, because these are equivalent fractions and these are equivalent fractions, we can therefore say 3 on 5 is greater than 1 on 2. So just to recap here, what we've done is we have created equivalent fractions and we've ensured that they have the same denominator. And we've done that by finding the lowest common multiple of the denominators that we've been given. Then once they have the same denominator, it's just very easy just to compare the numerators. And the one with the bigger numerator is going to be the one that is bigger. And that's what we've done. So now we can say 3 on 5 is greater than 1/2. Hopefully that has made sense. We'll try another one in the next part.